to 16 cores and 32 threads in only 65 watts, the AMD EPYC 4005 series is simply awesome. You get more cores, more performance, more features, and just frankly more of almost everything in these, which make them kind of a no-brainer these days. But of course, there's a lot more to this story, so let's get to it. Hey guys, this is Patrick from STH, and this is the AMD EPYC 4005 series. Now, a lot of folks are going to see this as an EPYC version of the Ryzen or the Zen 5 Ryzen series, and in some ways, I guess that's kind of right. But with things like formal ECC memory support, as well as server validation and SKUs that are specifically targeted at things like Microsoft Windows Server 2025 licensing, there is a ton to this series that makes it, well, special. And just like we did with the EPYC 4004 series, and we've done a number of times with reviews and stuff on the STH main site, and even on our YouTube channel, we're going to go into a lot of detail on this platform. Now, I want to point out that AMD sent us processors so we could do this video for launch day. Also, ASRock Rack provided us with a platform. We're going to get into those in a little bit and show kind of what makes these platforms awesome. We have to say that this is, of course, being sponsored. But when I heard about the EPYC 4005 a little bit ago, I, of course, asked, well, what SKUs do you have and what makes them different? So I think let's get to that next. Now, when we get to the SKU stack, it's relatively simple. There's only 6 SKUs and they cover a massive amount of ground. Prior to this launch, AMD told us that the reason that they were simplifying the SKU stack was just because their customers said like, hey, there are some really popular options and there's some options that are less popular. So they're really kind of focusing on that. Frankly, I think it's better than having a whole bunch of SKUs that are differentiated by maybe 100, 200, 300 megahertz. Now, the part that we're most familiar with because we've been using it the longest is the AMD EPYC 4565P. This is a 16-core, 32-thread part with a 170 watt TDP. The base frequency is like 4.3 gigahertz and the boost clock is all the way up to like 5.7 gigahertz. Now, I know what you might be thinking. This is obviously the highest end part and there's nothing even close to that, but that's not necessarily true because there's also a 3D V-cache part. That is the AMD EPYC 4585PX, and that X of course means that we have our 3D V-cache. And while we still have 16 cores and 32 threads, our 3D V-cache brings us all the way up to 128 megabytes. Now on that part, we still have a 170 watt TDP, but I think folks, these days kind of know that there's a little trade-off because you are sacrificing some power to the extra cache. But on the other hand, there are a lot of applications that can frankly take advantage of that 3D V-cache really well. Now I know exactly what you're thinking. Patrick, do you get 3D V-cache on both of the CCDs or the core dies? And the answer is no. It's just like the Ryzen where you only get it on one of the two. Now, I mentioned earlier that we've been using the EPYC 4565P, but frankly, the part that I've been most excited for has really been the 4545P. This is a 16-core, 32-thread part, but with only 65 watt TDP. Of course, you're losing a lot of frequency. You're going from 4.3 gigahertz base all the way down to 3 gigahertz. You're also going from 5.7 gigahertz down to 5.4 gigahertz on that max boost clock. And the importance of that 65 watt TDP figure is amazing in this space. These chips are often designed for either little tower servers that sit in businesses, but also very commonly as dedicated hosting boxes. And when you have these dedicated hosting clusters, a lot of times you don't have like the highest power racks. I mean, these are really optimized for low cost and low power. And so being able to provide a 16 core part but in such a low power envelope is super important in that market. And the other 3 SKUs range from 6, 8, and 12 cores, but they're all also 65 watt TDP parts. We recently did a piece using the EPYC 4004 series, really just showing how much more performance you're getting with these EPYC 4004 12-core parts versus the top of the line Intel Xeon E 2488. Okay, so let's talk about how these are even made. This is the overall slide of what you get in terms of the overall features, but then also what the differences are between the 4005 and the 4004 series. Now, the first thing is that we move from Zen 4 to Zen 5, and that gives us that full 512, so the AVX 512 data path, which is frankly just awesome. Now, a huge one in this is, of course, the DDR5 5600 ECC UDIM support. Now, this is important for a couple reasons. Like, number one, I know there are folks that say, hey, Ryzen, there's some platforms that claim to support ECC memory. And in fact, you can get Ryzen platforms that do support ECC memory. That's totally true. But on the other hand, it's not supported all the way through the chain, right? AMD supports the ECC memory operation on these chips. So when vendors go or like ODMs and OEMs go and create platforms based on this EPYC 4005 series, that is baked into this. The other thing to keep in mind though is that these are ECC UDIMMs or unbuffered DIMMs. When you get to the larger server platforms, those use ECC RDIMM. So there are actually extra components on those. We have an entire piece on DDR5 and servers. So if you want to go look at that, we'll go link that down below. But if you're coming from older generation DDR4 servers, this matters because they are not compatible. You can't take an ECC UDIMM and put it into an ECC RDIMM server or vice versa anymore. They just physically don't fit. They're physically keyed differently. One of the other just kind of interesting things is there is a little display engine in here. Now, of course, if you're going to go run these display engines against, like the high-end gaming chips or anything like that, like the high-end APUs that AMD makes, you're just not going to get that same 3D, quality or just performance or any of that kind of stuff. What you do get though is if you want to like hook up a 4K display using HDMI or DisplayPort, you can actually do that with these. There's still RDNA 2, but at least you have some of those capabilities in this, and that's important because some of the competitive Xeon parts just don't have any of that. One thing that I think a lot of folks are going to get stuck on is the PCIe lanes. You can get up to 28 PCIe Gen 5 lanes, but there's you have to have the right chipset and all that kind of stuff to make that happen. And a great example of that is this ASRock rack EPYC 4000 D4U motherboard that we're showing. That is a great example of where, frankly, if you look at the block diagram, you can easily see that they are having to share lanes and mux lanes just because, well, there's only so many lanes in this platform. And because this is a server platform, AMD also does the work to go and validate it with the major server OSs. So that way, if you go and you want to install your major server OS on these chips or the platforms with these chips, you can expect that they're going to work. And that's something that, especially if you're going to go install something into a data center or send a system to a data center to be installed, you don't really want to find out like later on that your operating system all of a sudden no longer works because of a new update or something like that. You want to make sure that you're staying in that supported lane. And there are other features that are also important in this, like for example, the secure memory encryption. A lot of folks don't really care about that as much on the desktop side, for being honest, but in applications like server applications, those are things that people do care about. Okay, let's take a look at upgrading a server to one of these platforms. Okay, so for this one, I wanted to do something a little bit fun. And for this, we're gonna use the ASRock rack EPYC 4000 D4U, which is this motherboard right here. And I thought, like, what do I wanna go and upgrade, or what should we build out of this? One thought was that we could do something like that Gigabyte server that we recently reviewed, or it's a one-use server, but I thought, nah, we already did that. Let's go do something a little bit more fun. And one of the videos that we also did recently was we did this AMD EPYC 4004 powered Lenovo ST45V3. And when folks saw that, they said, hey, cool, but on the other hand, there's a lot of things that they would want to change and things they would do differently. So what I thought was, why don't we go and upgrade this system? And this is a project that we did a little while ago with an AMD Ryzen 7800 X3D platform, which is an 8-core processor with the 3DV cache. And we built a little server based on this, and I've been using this for a while. I love this little server, but then I thought, hey, we need something that's a little bit faster than that. And so what I wanted to do was upgrade to the EPYC 4005 series and also go up to 16 cores. And so you see here that we're using the AMD EPYC 4565P, which is a 16-core processor. And so the basic idea is we're gonna go from this 8-core 64GB platform to a 16-core 192GB platform, just to get a little bit more. And just showing off some of the features of this motherboard, because I know folks, when we did the ST45V3 review, for example, folks were like, hey, I want to customize in this way. I wish it had a BMC, all that kind of stuff. Well, if you look at this motherboard, you're gonna see a lot of those features. For example, here we have the ASpeed AST2600, which is an industry standard BMC. And so this has things like the ability to remotely power cycle the machine, as well as your HTML5 iKVM. And while we have those features, we also have a number of expansion options, including 2 SATA ports. We have a PCIe Gen 5 by 16 slot. We also have 2 M.2 slots, and then 2 MCIO ports. So if you want to do things like you want to go and wire up a couple of front panel NVMEs, you can totally go do that. Also, unlike that Lenovo motherboard, we get our 4 DIMM slots, so we can actually go up to 192 gigabytes. And that's one of the things I really like about the AMD EPYC 4005 series. On one hand, it's validated for things like, using RAID and server operating systems and all that kind of stuff that you don't get on the Ryzen platforms, but you do get on the EPYC 4005 series. And so that's why a lot of folks will build these, especially in servers for businesses. But the other side to it is you can get pre-built servers, you can get servers that, well, you can go build. This is an MATX platform, which means that it fits in just about any case. And so what we did was we pulled the AM5 Ryzen combo out, and we're just gonna go install this into our wonderful chassis. So let's get to that. Okay, so here's the system that is upgraded with the AMD EPYC 4565P. And the reason we didn't use the 4585PX is that it just didn't arrive in time. But because we have a 170 watt TDP CPU, you're gonna see that we have a liquid cooling setup. And of course, for servers, it's not the same as gaming in terms of TDP versus like actual power consumption. So you will see that a basic, or at least a decent liquid cooling setup is gonna be just fine to keep this very low noise. The other thing you'll see is that we have 192 gigabytes of ECC memory. We also have 2 SSDs. In this case, we have 2 2TB SSDs. Then we also have our PCIe slot, which we will end up putting a high-speed NIC in the future, but we just found out that we're not allowed to show the one that we had in here. We also have the ASPEED AST2600 baseboard management controller for our out-of-band management. And a fun feature, because we have that RDNA lineage graphics on the EPYC 4005 series, is that we have an HDMI output, not just a plain VGA output. And that means we're able to use this chassis, which has a small LCD screen on the front, which doesn't seem like a big deal, but sometimes you just need a little display for local troubleshooting, and it's frankly better than nothing and easier than having to go lug a display over. Of course, you would usually use out-of-band management, but sometimes you just need something local. And so 16 cores, 32 threads, 192 gigabytes of memory, 2 SSDs that we can mirror, and a space for an additional high-speed NIC. This is a small server that packs plenty of performance capability and all into a low power, low noise footprint. Normally, I don't like to use these competitive slides from AMD or Intel because they always make their stuff sound great. But this is one case where, frankly, AMD is just way ahead and they're pretty valid. In fact, I think they may even be missing some things on the slide. So Intel, in its recent Xeon 6 launch earlier in 2025, introduced the Xeon 6300 series. Now, prior to that, there was the Intel Xeon 2400 series. And if you don't know what Intel did, and if you look at these two columns and they look very similar, they are literally the same chips, except they got a little speed bump. Something that Intel has done historically is that, they'll go and they'll release these entry-level Xeons, and then they'll come up with a speed bump that might be 100 megahertz, 200 megahertz, 300 megahertz, but it's the same core count and features and all that kind of stuff. It's just a little bit faster. But what they're doing on this launch is they're saying, hey, we have that Xeon E2400 series, but we're gonna rebrand it the Xeon 6300 series to make it sound more like the 6700 series, the 6900 series, and all of that kind of stuff. But the strange thing about this whole rebranding is that now Intel has this new 6300 series that's still using like previous gen technology. We still have 4 cores and 8 threads, and if you saw our recent Lenovo ST45V3 piece, we had the ST50V3, and we literally had the 4-core EPYC 4004 series, which had SMT, so you had 8 threads. And in the same price bracket, the Lenovo ST50V3 system with the Xeon E2400 series had 4 cores but 4 threads because they turned hyper-threading off. And even at the top end with the Xeon E2488, we still only got 8 cores. And so when you even got to the kind of upper mid-range 12-core AMD EPYC 4464P, you just had way more performance because you had 50% more cores. One of the features that AMD needed to reach at least some level of parity on with the Intel Xeon E series is really in the software RAID. So that's something that has a line there. Some people think about it, some people don't think about it, depending on what kind of OS and stuff you use. But with VRock and stuff, Intel has always had this, or has for a long time had this kind of RAID capability in their chipset that could be used by these OSs. When you look at the AMD side, that's the RAID Expert 2 for server. The idea is that you can use the software RAID features if you don't want to go and spend all the extra money and also power consumption, take that hit from having a PCIe slot-based solution. You can just go do that on the chipset and in software. And what that allows you to do, if you don't want to go through the power and expense of adding and also just using the PCIe lanes for array controller, you can now do that without having to go down that route using an AMD platform. That may not seem like a big deal, but if you look at our recent Gigabyte server review with the EPYC 4004 series, you would see that clearly that would be a case where, somebody that is buying that server would definitely look at a solution like this. But let's get to the thing that is kind of on the slide, but not really that it should be. The fact of the matter is that with the EPYC 4005 series, you have Zen 5. The cool thing about this is that you can literally take a VM and migrate it because you have the same instruction set between the lower end and higher end parts. Now, of course, you're gonna have different clock speeds, different caches, and all that kind of stuff, but you have that same instruction set. So you don't have to worry about, for example, migrating among that family and losing things like AVX 512 support. Because even though Intel is calling everything a Xeon 6, and that was part of the reason for this entire rebrand, the fact of the matter is that they have at least 3 different core types. You have the E core, which would be the 6700E and the kind of not really launched for general purpose Xeon 6900E series. It's only for maybe like a handful of specific customers. But then you have the P cores in the 6900 series and the 6700 series, which are the same. And then you have the 6300 series P cores, which don't even offer AVX 512 at all. So if you don't want to live in a world where you have to worry, is there SMT on a core or no? Is it a small core or a big core? Is there AVX 512 or is there no AVX 512 in this family? At some point, if you just don't want to worry about that, well, then the AMD EPYC using Zen 5 is just really nice, right? Now, just as we ran through some of our workloads, you did notice a huge performance leap in this generation of 16 core part. Now, of course, this is the 170 watt part. I really can't wait, just frankly, for that 65 watt 16 core part. Like that is, I dream of that thing. That is awesome, right? But even just going from 16 cores to 16 cores in the EPYC 4004 to 4005 series, you're still seeing a pretty massive jump in generational performance. This is not a, oh, we're gonna rebrand this thing and add a couple hundred megahertz. This is a new architecture, right? Now on the Intel side, the Xeon 6369P, which is the refresh of the Xeon E 2488. But at the same time, it's just adding a couple hundred megahertz, right? Now in AMD's slide, they're really highlighting the raw performance. And frankly, I think that makes sense for them because, even with the EPYC 4004 series, the EPYC was way ahead of Xeon E. I mean, it's just not even close these days because Intel's stuck at this like 8 cores and they just haven't gotten off of that for a while. But what's more interesting, I think, is looking at the performance per core. So AMD here is using Michael Larabel's 4NX test suite, which, Michael is an awesome guy, by the way. If you've never had a beer with him, he's phenomenal. But just kind of refactoring this and showing the performance per core, you're gonna see that you're just so much higher on the AMD side at that 8 core limit, which means that, if you have things that are licensed on a per core basis and you're just trying to minimize the number of cores that you have, but you want to get the maximum performance per core, well, you're doing pretty darn well if you have the EPYC 4005 series. But turning that on a license basis on its head, right? You can look at it another way. Windows Server 2025 is something that is very popular in this segment to run if you're not running Linux, of course. And if you are doing that, you get a 16 core license pack. So the idea is usually that you want to maximize the performance per core for those 16 cores. So one way to frame this is that by going up to 16 cores, you're getting somewhere in that like 75 to maybe 85% more performance, which of course is good if you're just trying to get the most performance you can out of that license. Remember, the licenses on these things can easily cost close to $900 or something like that. I think it's like retail. These chips are often in the like $600 range. So the license cost is a huge portion of licensing one of these servers. But the other way to just kind of flip it on its head is just, even if you're looking at a per core basis, you're still at the like 90+% performance per core, in which case, you're not even really losing a lot by going and doubling the core count, right? You're just getting way more performance. That's super important because in the old days, when you went from 8 cores to 16 cores, oftentimes you were sacrificing a ton of per core performance to just double the cores. With that, let's get to the key lessons learned. Now, for all of our videos, I like to have key lessons learned. And to me, the number one thing is really like, where the heck do these get used? Because I think there are really folks that, because we've been reviewing systems and chips in the segment for well over a decade, there are a lot of folks that look at this and say, hey, that's an Intel Core series processor that's now a Xeon, or that's an AMD Ryzen processor that's now an EPYC. And in some ways, that's frankly kind of right. And there's a lot of reasons for that. One of the big reasons is that you get to share sockets and platforms. And so by just reusing that same platform, you get a lot, frankly, in terms of cost savings, especially in these kind of lower cost segments of the server market. And while you can usually save a couple bucks if you're going to go to the consumer segment, the nice thing about the server segment is that like you get things like ECC memory support. You know that if you put in a motherboard that supports the processor, you're going to get ECC memory support, and you just don't have to think about it and don't have to care. It's just going to work. And of course, if you're going to use a supported operating system and you want to stay in that support channel, you may just want to have a platform that's supported and not have to answer questions on like why you're using an unsupported platform for a piece of software that you're trying to get support for, right? Now, of course, where do you use these things? We recently did that Lenovo ST45E3 piece where that's a good little tower server that, the advantage of that is if you're a Lenovo shop and you want to continue using Lenovo servers, you can go and stick that just about anywhere. The other side to that though is the fact that you can literally take that box and put it in a bunch of businesses. A lot of small businesses, think of like a frozen banana stand or something like that. That would be a good case where maybe you just need a server running a little piece of software, a couple pieces of software to run that business. And if that's the case, having a little server like this is pretty useful. And also from a licensing perspective, a lot of times you just want fewer cores, and that's one of the benefits of this. The ASRock rack platform that we looked at in this video, that's a really good example of how you can go and build your own. So if you looked at that ST45E3 video and you're like, oh, I kind of like the chip, I like the form factor maybe, but I don't necessarily like the design choices that Lenovo made, then that's a really good use case for something like that ASRock rack motherboard where you have a lot more expandability and flexibility in your configuration. But the big use case is probably still the dedicated hosting market. And so what those dedicated hosting providers try doing is providing basically the most functional, lowest cost system that they can. And for that kind of market, these are the type of chips that just absolutely dominate. The idea that you can get a dedicated server for someone that, they can rent it, they can have full access on the BMC, they can have full, single tenant access to the entire system, that's really attractive to a lot of folks. And it gets more attractive if you can price it at a lower cost point. And so that's really the idea of these entry-level server platforms, trying to ensure that the overall platform stays low cost. Now, whenever we do these, I know a lot of folks are always like, I want more PCIe lanes, I want more memory, I want more cores, or all these kinds of things. And the answer to that is if you do, then you're going to the EPYC 7000 series or 8000 series, 9000 series, one of these higher end chip lines, just because those have the bigger platforms with more IO, more memory, all that kind of stuff. The point of these entry EPYC systems is really to get systems online at a low cost that have high performance cores and have enough that you can do something useful with the servers. And that's really the whole point of these. And I know folks on the STH team and a lot of our readers and a lot of you on YouTube have made really cool platforms out of these. So if you have ideas, definitely go put those down below. We'll probably do some fun platforms over the summer. And if you did like this video, well, why don't you share it with your friends and colleagues, but also give it a like, click subscribe, and turn on those notifications so you can see whenever we come out with great new videos. As always, thanks for watching and have an awesome day.